Okay, so this is section 3.2. So 3.2 here. So first off, let me answer what might be a really natural, I think, question I would have is why are you doing all these fancy formulas? I mean, why don't we just subtract them? I mean, what is that? Minus 15 degrees, right? 45 minus 60 there. It's minus 15 degrees. And just do that. Just subtract those angles, cosine of minus 15 degrees. Just get your answer that way. Why don't I? That's a great question, which I am assuming any reasonable person would have. So why am I doing all these fancy formulas? Why don't I just do that and then go find the cosine of minus 15 degrees?
Because aren't they the two different angles?
They're different angles, yeah. How about, how would we do cosine of 15 or minus 15? Either way, same thing.
It would have to be inverse, right?
No, we can, well, you mean the negative part?
Yeah.
Don't worry about that. How about I just, don't worry about negative. What if it was just positive? Don't worry about that at all. Do you realize 15 is not one of our memorized values? I mean, not memorized, but I mean, on the circle.
Yeah.
That's not one of our spots. Yeah, it's just 30, 45, 60, right? Remember when we did the unit circle thing, right? And that's how we're going to do all of our angles. In fact, I should probably go grab it. Maybe I'll do it in a minute. But anyway, yeah, that's not one of our spots, right? We learned what 30 is, what 45 is, what 60 is. Remember the small, medium, large, those numbers, We don't have 15. That's the reason. We basically don't. How would we have to do 15? Calculator. The only way we could do 15 is with our calculator. Now, of course, we could do that. And in fact, let's do that real quick. I'm going to do cosine of negative 15. By the way, I don't know if you know that's the same as cosine of regular 15. Remember, negatives and a cosine can come out. It's all right if you don't remember all that right now. I'm just going to hit cosine 15. I'm getting 0.9659. Now, that's not what they want, but they don't want a decimal. They want the exact, which we'll get in a second. But it'd be nice to see that they're the same, actually. So is that good? You guys able to get that value? So why can't we just give that as the answer? Well, because they want the exact value. Meaning, see, my decimal goes forever. There's more. You're getting it on your screen too, right? 0.9659, 258, goes on and on and on forever. We call that an irrational number, a number that goes on forever without a pattern. So anyway, they're going to ask, look back at the question. They say, find the exact value. What they mean is, don't give me a rounded decimal. Well, I'll tell my calculator gives me. Right, you can't use the calculator, they're saying. That's exactly the point. You get an idea? Because all the calculator will give us is a decimal that goes forever, and we can't write decimals forever, so we have to round somewhere, and then it's not exact. You tracking with me? As soon as we round, we've no longer done what they asked. They asked for exact. So that's the whole point. When they say exact, they're basically saying not calculator. I don't know if you've picked up on that, but that's their lingo for not calculator. Because whenever you get a decimal, you're going to have to round it, and then it's not exact. So when they say exact, they mean give it to me with that unit circle, not with your calculator, so that you have an exact value and not a rounded decimal. Okay, so this is true, but it's rounded. It's not exact. So how do we get the exact? We're going to have to use that formula. That's why we have that formula. Because we don't know 15 degrees. 15 is not one of the spots on our circle. We can't go over there and say it's, root 3 over 2 or whatever, half, or we can't do that. We have to actually use the formula. Okay, so with that in mind, let's redo this problem using the formula. And then it's going to be the same answer, though. When we're done, I want to compare back. What was it? I already forgot. 45 minus 60. Okay. 45 minus 60. Okay, so how do we do it? So I'm going to use this formula right here, which says, let me just write it out for us. Cosine of A, well, it says A plus B is cosine, sine, sine, and then you do the AB minus sine. Now remember, this is always opposite, right? For cosine anyway. Cosine is opposite. So what does that mean? They gave me in the original question minus. So A is 45 degrees, B is the 60 degrees, and they gave me minus. Thank you. They gave me minus. So what does that mean I'm going to do on the right side? It's going to be, what's it going to be? Going to be adding, yeah. Y'all tracking with me? Oh, what did I do? I can't talk and solve the problem here. Cosine, cosine, sine, sine. So then put in the A and the B. So the A is, so you notice how you put in the angles according to the formula? It's just in their exact order. A, B, right? Just their exact order. So it's 45, 60. I'm just going to go 45, 60, 45, 60. And what sign goes in the middle? Plus, because it's always the opposite. Yeah. Tracking with me on that? In fact, it'd probably be best for the sake of the, here, let me do this. For the sake of the, hopefully you got that copy down. I'll come back to it. For the sake of the YouTube video here, let me just write this out. These forms. Sine of A plus B is sine, cosine, cosine, sine, and cosine of A plus B is cosine, cosine, sine, sine, and then the angles just go in order. A, B, A, B, A, B, A, B. Whatever sign is in the middle, we do the same for sine, and we do the opposite for cosine, like that. And then I did give you the tangent one briefly. The tangent of A plus B, which we'll use later. When I always forget. Okay, tangent, tangent. Tangent, tangent, 1 minus tangent, tangent. And that is A, B, and that'd be plus. So this is always same sign, and the bottom one is always opposite. Okay, so there's the 3 formulas. We're going to use those for the whole section. So coming back to this one. So now, everybody good to hear? So we have cosine of A plus B. We just put in the A, B, like that. Sign in the middle, we do opposite. So now, do you see we can figure out the exact value for all of those? Those are all angles we can do on our unit circle, huh? 45 and 60. See how it's changed the question from being, remember back here it was like, well, it's 15 degrees. 15 degrees is not on my unit circle. So I need my calculator, but they want exact. So I can't use my calculator. How am I supposed to do this? Well, that's why this formula is used. It changes the 15 into angles 45 and 60 that we can do exactly with our unit circle. So let's do that now. Let's find the cosine and the sine. Basically, it's just cosine and sine of 45 and 60, isn't it? So let me draw. Well, how about I go right to here, and I'll just make a quick little unit circle. If you have one before you, that's great. You can just go with that. So 45 is right in the middle, isn't it? Right there. So 45, remember the small, medium, large values? So this, it's, what is it, a half, root 2 over 2, and root 3 over 2, small, medium, and large. Remember how that goes? It's like root 1, 2, 3. Because the 1 is really the same as the root of 1, isn't it? Square root of 1 is just 1. So that's root 1, 2, 3 over 2. Remember those small, medium, and large. Okay. And so then they're asking me, what's going to go here? This is over a medium amount, up a medium amount, isn't it? To be right in the middle. So medium, medium. So this is root 2 over 2, root 2 over 2 for what? Cosine, sine. Cosine's always the first one, then sine for any point on the unit circle. And then the other angle we're looking at is 60 degrees, which is right here, isn't it? It's almost to 90, almost to straight up. That one, what are the coordinates for that one? It's over just a little bit, up a lot, isn't it? Over a small amount, it's only over a half, up a lot, up right over the small amount, up the large amount. Over a half, up root 3 over 2. So it's over a small amount, up a large amount, isn't it? Over, and that's the cosine, sine. We good with that on the unit circle? Remember how to find all those? So going back, what do we need here? We need, whoops, where are we? Totally lost. There it is. Cosine of 45. So go back to that one. Cosine of 45, root 2 over 2. So this is root 2 over 2 times cosine, right? That was this. Cosine of 60. Cosine of 60 is right here. A half. So that's a half. Plus sine of 45. That's root 2 over 2. And then sine of 60. Go back to 60 here, the sine, root 3 over 2. I just keep going back and forth between that unit circle. find the different values I need. So the cosine of 60 is right here, a half. Sine of 60 is root 3 over 2. And the cosine and sine for both, for the 45, is root 2 over 2. So it's be root 3 over 2. There we go. Now we just do a little bit of algebra. I don't think it'll be too bad. And we're done. So that's going to be the exact value. Let's just multiply these fractions. So just multiply top times top and bottom times bottom. Root 2 times 1 is root 2. 2 times 2 is 4. Top root 2 times root 3 is root 6 over 2 times 2 is 4. Remember that from algebra, just multiplying? I'm just multiplying roots here. You just multiply the numbers. 2 times 2 is 4. I just multiplied numerator with numerator, denominator with denominator. And now they have the same denominator, so I can just put them together. There it is. Root 2 plus root 6 all over 4. Did it? Oh, so you have one of those nice ones. It just cranks right to the exact value. Nice, nice. That's the Casio Natural Display? Yeah, that's very fancy. Yeah, you could check it if you want to hit the buttons on your calculator. It'll come out that same decimal that we got back, wherever we got it. Back here, 0.9659. Anyway, that's the, wherever it is, I lost it now. There, this is the exact value, the one they want you to type in. Notice this is exact, right? This isn't rounded in any way. This is right on the money, the exact value. So the formula, the adding, subtracting, cosine, and sine formula lets us find exact values for things we couldn't have found before. See how it extends our ability. We didn't know how to do exact value of cosine 15. Good there? Is that making sense? Questions on that one? All right. So basically this section is all of this. But we're going to go forward and backward, and then we're going to do it with letters and triangles at the end. The last 4 problems are kind of tricky. Here, in fact, let me write it where we got more room. Cosine, cosine, sine, sine, 6232. So cosine, is that what it was? Cosine, cosine, sine, 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 6232. And there's a plus. Right. And they're saying, basically they're wanting me to look at that thing and say, hey, can you work that backwards? Do you see that basically that is the right side of one of these formulas, and they want me to go backwards to the left? So they're just going to have us do these formulas forwards and backwards and every which way to get super comfortable with these formulas. That's what the whole section is about. So how am I going to take that formula and work it backwards? Which one is it? Sine, cosine, or tangent? Cosine. Yeah, it's the cosine. It's cosine, cosine, sine, sine on the right side. That's the cosine formula. So basically, that means this is the left side. This is cosine of something plus something.
You mean something minus?
Good job. Is it plus or is it minus in the middle? Minus. Yeah, Chanel's observation is right on the money. Because remember the cosine formula, the right side and left side have opposite signs, don't they, when you use the cosine formula? So basically, if they're giving me plus, that means there must be minus here, because those are always opposite for the cosine formula. For the sine formula, they're the same. Okay, and so far so good. So we're just playing the identification game. I just looked at this one. Which formula is cosine, cosine, sine, sine? Right, just looked back here and said, which formula is cosine, cosine, sine, sine? Oh, the cosine. So then I go, okay. So it's cosine of 2 angles subtracted. And what are those 2 angles? Yeah, the 2 they keep using, 62 and 32. That's the A and the B. That's A and that's B. 62 minus 32. So that's kind of weird, huh? All these cosines, all these sines together become 1 cosine. That's what the formula is saying, huh? 1 cosine, 2 angles added, is 2 cosines, 2 sines. That's what the formula says. So I just did that backwards. I said, okay, so 2 cosines, 2 sines, all comes back to 1 cosine with the angles subtracted there. And what is cosine of 62 minus 32? Just 30, huh? Cosine of 30. And now we can find cosine of 30. That's one of our memorized or, exact values on a unit circle. So I'll just go to the unit circle again. Where does 30 degrees go? That's the one right here, kind of close to the 0. right? 30 degrees, which means it's what? It's over a lot, only up a little.
Yeah.
So it's over the large, up a little. Over root 3 over 2, up a little. Remember, this is cosine, sine. So what do they want? They want cosine. So what is it? Root 3 over 2 on the unit circle. And that's what they want. So we just used the formula backwards, didn't we? So they're just going to have us go forwards and backwards with these, especially these first two formulas, and then a little bit with the tangent. Good questions I can answer? It's making sense? So they just to show you exactly how the question, they have you identify the A, they're doing alpha and beta, but whatever, A and B. So that's the A, that's the B. They want you to say 62 degree, well, I guess they already have the degree symbol there for you. It's right here. 62, 32 degrees, and write the expression, so it's cosine of 30, they want you to say, because you subtract them. Do you see how they're breaking it? Almost their breaking down can be more confusing. Do you see what they're asking? They're asking it piece by piece. They're saying, okay, identify the A, identify the B. This is the A, this is the B. Here's the A again, the B again. So the A is 62, the B is 32. And then what does that mean the left side is? Cosine 30, right? That was the left side we found out. Cosine 30. And then, all right, and then what's the final answer? And that's where your root 3 over 2 goes. That's how they want you to answer the various parts. It's almost more confusing in parts. All right, so there we go. They're saying, all right, show that this identity is true. Show this identity is true. Verify the identity. Sine of alpha plus beta over sine alpha times cosine beta is that. So why would that be true? Okay, well, they're gonna lead us through it piece by piece. First off, they're saying write the left side numerator in terms of a sum or difference formula. In other words, look, that's sine of two things added, huh? So we can use formula number 1. Can't we? Right there for the top, for the numerator, we can use formula number 1. We can say, oh, this is, and what is sine of two angles added? Sine, it's a little different, right? Sine, cosine, cosine, sine. See how it reverses? Sine, cosine, and then switches cosine, sine. So we write that out. We write, okay, sine, cosine, it's going to be a big long numerator here, cosine, sine, like that. Right, let me go back here. I'm going back to this formula right here. So the sine of two angles added is sine, cosine, cosine, sine. And then I put in the angles. And what are the angles? Well, they're just A and B. Or here, I'm just going to write A and B. I guess they're going to give you an alpha and a beta to use. Let me scoot this over a little bit. What sign should I, plus or minus I mean, should I put in the middle here? How does it work with the sine formula? Yeah, whatever is in the middle of sine, it's the same thing on the right side, isn't it? Whereas cosine does the opposite. Cosine, whatever you start with, it's opposite. Sine, whatever you start with, it's the same. So you start with plus, it's the same. Good so far? So that's step 1. They're leading me through the steps of the proof. That's what they want you to type. You got to type all that out on step 1 of the proof. It's a little proof. They're leading me through step by step. So that all is step 1. Good so far? And then they're saying, look, if this is all the numerator over this denominator, you can just break it up into two separate ones. You know what I mean? It's kind of like if you had x plus y all over w or whatever. You could make it x over w plus y over w. Get the idea? Right? That'd be okay to do, wouldn't it? Right? If you have one big old fraction, you could break it up into two separate fractions with the same denominator. Well, that's what they're going to say to do now. They're going to say, look, you got a big old piece here, a big old piece here, and it's all over that common denominator. So see how they've taken the left piece and put it right there, and the right piece and they put it right there. And they want us to put it, they want me just to write the w, the denominator, twice in two separate fractions. Just basically make it two separate fractions, same denominator. So that's what I'm going to do here. Take this one denominator and go, okay, sine A cosine B, sine A cosine B. Just make it two separate fractions, same denominator, common denominator. Is that good to there?
Can you show us how to do that on my math lab?
Yeah, I will. I'll go back there and do that with you in just a second. So everybody see the general idea of what we're doing? And then, do you notice what can happen? Thank you, Wendy. What can happen there on that left side? What is this now? That's just 1, huh? Right? So that's just 1 plus. Now, what about the other side? Well, am I going too quick? Remember the formula? What is cotangent of anything x or whatever equal? What over what? Right, I mean, I guess there's a lot of things, huh? Yeah, remember what tangent is what trig function over what trig function? Tangent is sine over cosine, so cotangent is upside down to that, huh? Cosine over sine, remember that it's always that way. Tangent is sine over cosine, and cotan being upside down is cosine over sine. So look right here. We have cosine and over sine of the very same angle. So what is that? That's cotan of that angle. And what is sine over cosine?
Tangent.
And that one's tangent of that angle B. And that's our proof. See, we wanted 1 plus cotan of A, tan of B. See how it came out? So let's go back. I'll show you math. Oh, yeah, and then like, which of these do we use? This is what I didn't like. You know that handout I just gave you? This is why I gave it to you, because this is what they did in the whole last section on Math Excel, is they gave all these weird words. And you had to say, is that the quotient identity or the reciprocal identity or the even odd identity or the Pythagorean identity? I just didn't think that was helpful. That's why I made a handout. I just didn't want you to answer a bunch of weird questions like that. So it turns out, so I'll just give you this one, and I'm not going to ask you this on the test. That one is the, I don't even know half the time because I don't use the words. It's the quotient identity. You think, why is it quotient? Quotient means dividing. It means we just divided these and made it 1, and we divided these and made it cotan, and divided these and made it tan. Quotient is a division. Anyway, I don't think the words are that important, so that's why. That's the only one in this homework. So that's it. You just got that one down, you're good. That's the only one where they're going to do this. Yep. That's why I gave the handout in the last section, because I didn't want to do all these words. All right, yeah, let's. So try that one. So sine 45 minus 30. So it's just basic using the sine formula. Just use exactly that formula and then go to the unit circle and find the values. Okay, so the formula, the sine formula. So we're going back to the sine formula, which says sine, cosine, cosine, sine, right? That's the order. It switches orders halfway through, doesn't it? That's how it goes. Sine, cosine, and then it switches cosine, sine, like that. And the angles, you just put them in the exact, or we never change the order on the angles. Have you noticed that? Whatever order they're in, we just keep it. So 45, 30, 45, 30. Just keep it exactly the same. Always. That's for all these formulas. And then what do we do with the sign in the middle? Is this one of those that stays the same or switches? Same. The sign is the same. My buddy who I went through junior college with and took all these math science classes, and we transferred together to Cal Poly. He's an engineer now in the East Coast. Anyway, he used to always say, I remember him practicing memorizing this formula in our junior college days, and he would always say, sine is your friend, and cosine is not your friend. That was always his statement. Cosine does the opposite on you, but sine is your friend. All right, that helps you and works for you. All right, so now we just find these four values. So sine of 45 degrees, and cosine of 30, and cosine of 45, and sine of 30. We get all these off the unit circle, huh? So I'm just going to go to the unit circle over here, and you could just have it before you or draw it right now, either way. So I'm going to 45, which is right in the middle. The one right in the middle is easy, huh? That's over medium up. So that's over root 2 over 2, up root 2 over 2. And the other one's 30 degrees. So that one is right here, 30 degrees. That one is over a lot, only up a little, huh? It's over the large amount, the 3, only up a little, only up a half. So that one's over root 3 over 2, up a half. Again, this is cosine first, then sine, cosine first, then sine. All right, so let's go through them. Sine of 45, that's root 2 over 2. Sine 45 is always root 2 over 2. Cosine 30, so that'd be the root 3 over 2, wouldn't it? Minus. And then next comes cosine 45, that's root 2 over 2. And then sine 30, here's 30 degree sine is a half. Good to there? Then we just multiply these fractions. So what do we got? Root 3 times root 2. Root 6 over 4 minus multiply these two. Root 2 over 4. Put them together into one fraction because they have the common denominator. There we go. And you can't subtract these, by the way. You can't subtract roots. I don't know if you remember from algebra. Roots have to be like roots to add or subtract. We'll get more into that later. But for now, you got to leave them just like that. Good. Easy enough. So that's an exact value for that. All right. So now they're going to... Okay. So they want me to find sine of 135. Now, 135, if you do the unit circle, don't draw this. This won't work. But let me just show you it won't work. So where is 135? Well, 90 straight up. This is 180. So, actually it will, won't it? Why can't I just go right there? That's funny. We could, actually. Yeah, my mistake. We could. But we're not going to do it that way because they're being picky on this one. And they want us to do it using their formulas. They want us to do it. What do they say? Use one or more of the 6 sum or difference identities to find it. So we have to use the adding or subtracting of two angles to make the 135. We can't just go, because this is 135 right in the middle, right? That's 90 plus 45. That one we could just get the value directly using the unit circle thing. In fact, what is it? Root 2 over 2. Yeah, right? I mean, it's easy, right? This is back, medium. That's the one in the middle, right? The ones in the middle are always medium. This is back, root 2 over 2, up, root 2 over 2, right? So this point is cosine, back, root 2 over 2, up, root 2 over 2, cosine, sine. They want the sine, root 2 over 2, done, next problem. If you type that in, they won't take it. In fact, watch. Yeah, no, they'll take it. Great. So there's going to be other ones where we have to, but give them that. We're good? All right. Here, let me put the problem up there. There it is. So again, cosine 105, use the sum or difference. Okay, so cosine 105, now that one's not, right? Because where is it? Well, this is 90. This is 90. And this, add 30 more. The next one we know is 120, huh? Add 30. So the 105 is like right in the middle of those two. That's not one of our places that we have an exact value for. See the problem? We're going to have to somehow make it out of a combination of two other angles added that we do know. Everybody tracking with me on the problem first off? 105 is not one of our spots. 90 certainly is straight up, and the next one is 30 away from that, 120. So we skipped right over the 105. That's not one of our spots. We'd have to use our calculator, right? And they're not going to let that happen. They want an exact value. So how am I going to do cosine 105 then? What two angles among, just think about the basic ones we use all the time, the 30, the 45, the 60, the 90, the 120, the 135, the ones we do know that we use all the time. Which of those added or subtracted can make 105?
60 and 45.
That's a really good one. 60 and 45, they add up to be 105. Now, there's other ways, huh? I can't think of one right now. There probably are other ways. Yeah, 135, take away 30. You could do subtraction. Now, I think it's going to be easier. I'm just going to do the first way that Kevin was saying. But I just want to let you know there are other ways, and you'll get the same answer. So, yeah, I'm going to say, well, look, 105 is not one of my spots. So I'm going to have to say, well, 105 is 60 plus 45. It's 60 plus 45, isn't it? 105 is 60 plus 45. So then I can just use the cosine of two angles added formula. And I'll be able to get the 60 plus 45, which is the original 105 they wanted me to find. All right, are we ready? So we'll dive into it. Let me get this out of the way. So go ahead and use the cosine formula now. I'll let you do the next step. Use the cosine formula, break it up using it's called the sum of angles. These formulas are called the sum and difference, adding and subtracting. Sum and difference of sine and cosine formulas. So use the sum difference formula for cosine. Yeah, Austin.
How do you know if the 45 doesn't go where A is?
Oh, you totally could. Good question, Austin. Yeah, they're totally reversible. So you could swap them and it'll come out the same.
Oh, okay.
Yep, it'll work either way. Yeah. So it'll be, so the right side will be cosine. He's the cosine one's the one that does double cosine, then double sine, huh? So cosine, cosine, and then sine, sine. And how do you do the angles? You always keep the same exact order, don't you? When you do these formulas all keep the angles. They just move around the trig functions, but they keep the angles in exactly the same order. So 60, 45, 60, 45. Whatever sign is in the middle. Now, what do I do? The sign in the middle, do I do same or opposite? Yeah, cosine's not our friend, as my old buddy would say. Cosine is not your friend. He switches the angle in the middle. So it'll be minus in the middle there. Opposite. Okay, so let's take it piece by piece there. So now that means our two angles are 60 and 45. So we got to go to the unit circle and do 60 and 45. So 45 is right in the middle. We've done that one a couple times. Root 2 over 2. Root 2 over 2. 60 is right here. So what is 60? He's over a little bit, up a lot. Over a half, up root 3 over 2. Over a half, up root 3 over 2. This is cosine first and then sine. So there we go. There's all the values we need. It's a comma there. Let's find them out. So cosine of 60 first off. What's that? That is a half times cosine 45, that's root 2 over 2, minus sine of 60, that is root 3 over 2, times sine of 45, root 2 over 2. Like so. We good? So then we multiply these two on the top. Root 2 over 4 minus multiply these two on the top. Root 6 over 4. That looks a lot like the other answers we got. There it is. We were able to get an exact answer for the cosine of 105. Even though 105 is not one of our originals. This is why they derived this formula. This is why we have this formula. Make sense? Questions on that? Yeah, Austin.
Use any number on the unit circle as long as it adds up to 1.
Exactly, yeah. So I could have done, like I said, I could have done the 135 minus the 30. I could have done a lot of other things. Yep, any combination of angles that add or subtract to be 105 and then use the formula. It'll work. Exactly. All right. Okay, so we do have a tangent formula. So I'm going to use the tangent formula. Tangent formula says that you do tangent on the top, and 1, and then a tangent on the bottom.
You use the unit circle to find the degrees.
You can't. Oh, yeah, for sure. Or I would just, if you have the unit circle that already has radians on it, I'm probably just going to do that and just grab it right off. But if you want to change from degrees, you can do that too. Yeah, or just look on the unit circle to make degrees. Totally. So, okay. So, now, how does the tangent formula go? Let's look back at how the sine, or you got it right here. Look at how the tangent formula go. The sign on the top is the same. The one on the bottom is the opposite of what you started with. Does everybody see that? Let me go back here and point to it if I can find it. Where is it? There it is. Yeah, see the sign on the same for the sign on the top. And opposite for the sign on the bottom when you're using the tangent. And notice how the tangents are added or maybe subtracted on the top and then it's 1 plus or minus, and then they're multiplied right here. Do you see that? It's a little bit different structure. Okay, so let's do that. So we've got minus here, and it's supposed to be the same on the top, so that would be minus. And on the bottom, it's opposite, so that would be plus. So right there. So opposite, and that is same. Okay, and then what are the two angles? Just remember, you just write in the angles exactly the same order, no change in anything. So 11 pi over 6, 7 pi over 4. Kind of running out of room here. 11 pi over 6. Whoops. Tangent of 7 pi over 4. So there we go. So I put all those in there. And now, now we just got to find all those values on the unit circle. Now those are a little painful, some of those numbers. I mean, you could put in the pi and find the angles. It could end up being a lot of work. How about I go, so we're looking for tangent of 11 pi over 6. So go to 11 pi over 6, which is right here. This is cosine sine, isn't it? Cosine sine. So tangent, what's tangent always? Sine over cosine. Right. So tangent, so tangent will be sine over cosine will be minus a half over root 3 over 2, right? I put the sine over the cosine. That good like that? And then what do you do with the, you flip it up, huh? You grab that and you grab this guy and you flip it up. So it'll become minus a half times, and it goes upside down, 2 over root 3. These cancel, and you get minus 1 over root 3. Good there for starters. Now, should I leave that root on the bottom? I mean, if it was a final answer, for sure not. But we're just halfway through the problem. Bless you. I'm going to leave it for a moment, just for the moment. I can clean it up later. Everybody good so far with how I found the tangent? Right, I went to 11 pi over 6. Wait, was that it? They wanted? Yeah, 11 pi over 6. Yeah, that's the right angle. And I did sine over cosine, flipped up the denominator, cross cancel, minus 1 over 3. I'll clean it up in a minute if I need to. The reason I don't, you might wonder, well, you always clean up. What are you doing? Well, that's not the end of the problem, huh? If it was the end, like final answer, yeah, for sure, I'd multiply top divided by root 3 and be done. But I'm still got more work to do, so maybe something nice will happen and that'll cancel and I won't have to clean it up. I don't know. I honestly don't know. So I'm just going to, when I'm in the middle, I just kind of leave it for a minute, see what happens. So I'll just bring it back and go, okay, so this part up here is minus 1 over root 3, right? Good. And then, what else do we need? We need tangent of 7 pi over 4. So where's 7 pi over 4? Oh, right here. Yeah. So it's down here. Fourth quarter. It's this is cosine sine. Yeah, there's 7 pi over 4. Cosine sine. So what do? You put sine over cosine. That's going to be negative 1, isn't it? That's the same thing over itself. Everybody see that? I know it's kind of hard to see down there. So the tangent, let me get this out of the way. The tangent will be sine over cosine, negative root 2 over 2 over root 2 over 2. Right? That's just negative 1, isn't it? Sine over cosine, that's just negative 1. So bring it on back. This guy is, now careful, I was about to mess up too. Look at how, here, I keep changing my game plan here. See how we have a minus sign built into the formula? That's in addition to the fact that this tangent came out minus 1. You got double negative there, huh? So you got the minus from the tangent formula, right, which is always the same sign as the top, and the fact that the tangent of 7 pi over 4 is negative. All over 1 plus, now what was the tangent of 11 pi over 6? Negative 1 over root 3, same value. And the tangent of 7 pi over 4? Negative 1. Everybody good with all that? So I plugged everything in there. So these two formulas, the ones in the blue there, were built right into the formula. These two signs, I mean, We're built right into the formula, and then there's everything else plugged in. We good there? Everywhere that we had tangent of 11 pi over 6, I plugged in minus 1 over root 3, minus 1 over root 3. Everywhere we had tangent of 7 pi over 4, plugged in negative 1, negative 1. Okay, so now, how can we clean this up? Well, double negative, you know that's positive. And down here, negative times negative, it's just positive, right? 1 over root 3 times 1 is just 1 over root 3. Good to there so far? Everybody good? Now, I think it's a mess. In fact, what it is, it's fractions over fractions, which is called a complex fraction. So how am I going to clean up that complex fraction? I don't know if you remember this from algebra. In this case, I can't just grab these guys and flip them up because of that plus sign, because they're added on the bottom. They're like a package. You can't just independently grab them and flip them up. Everybody hear me on that? That's really important. That'll really mess you up if you do that. But it's so similar, huh? It's easy to get tripped up by that. So let me say it one more time, because you might think, wait, we always do that. Mr. Like, you did that. Well, you did that. Where did I do that? I just did that somewhere. You did that right here. You just grabbed this denominator right here, and you just flipped it up. Right, because it was just one thing. It wasn't another thing added. Pluses and minuses wreck algebra. I mean, they really do. They make everything hard. So anytime pluses and minuses get involved, you can't do nice and quick and convenient things. So because of that plus there, because those are added, I can't just grab them one at a time and flip them up. They're kind of like glued together. I always tell my algebra students there, I might have told you, right? They're Costco glue, have I said that? Yeah, so they're glued together, package deal. So you can't just flip them. So what do you do then? What do you do? Well, do you know, Kevin? Well, I could do some things like that. But look, isn't this guy the problem and this guy? They're the problem right there. If they weren't there, this would be a normal fraction. Their presence is making it, they're a denominator within a denominator. And so is he, denominator and a numerator. Right? They're making it fractions within fractions, right? So if I could get rid of them, it would be a normal fraction. So do that. Get rid of them. What will get rid of them? Multiply all the terms top and bottom by root 3. That'll take care of it. So root 3 here. You have to do the same thing top and bottom, right? So you don't change anything. So you just multiply all of them by root 3. And then these will cancel, and these will cancel. And so what do we get then? We get negative 1 plus root 3 over root 3 plus 1. Good so far? See what happened there? So these root 3's canceled, negative 1. Root 3 times 1, root 3 times 1, and these root 3's canceled, 1. Now, we still have a root on the bottom. I don't know if they're going to... Is that what you wanted to hear? All right. So we're good so far. We got a root in the bottom, right? We got to get rid of the root from the bottom. It's a long problem. All right, so I'm going to go to fresh screen. This is number 9 continued. And we had negative 1 plus root 3 over root 3 plus 1. Wasn't that it? Yeah. Okay, we good to there? Now we can't leave a root on the bottom. So we've had a lot of algebra problems here. First off, this thing was fractions over fractions. So we multiplied top and bottom by the denominator, which is root 3. Got it to be a normal fraction now. It's not so messy. Now it's a normal fraction. And now we can't leave roots on the bottom. So do you remember from algebra what we do when we have roots on the bottom? Well, yeah, but if you have a plus or minus, it's harder. You got to do the whole denominator, opposite sign in the middle, called the conjugate. Probably been a while since you've done that. Yeah, if you just have a root, so it's the plus or minus trouble. Pluses and minuses make everything hard. You got to multiply top and bottom by root 3 minus 1, like that. So let me write that out. When there's a root and plus or minus in the denom, must multiply by what's called the conjugate. Remember that a little bit from algebra? The conjugate, which means opposite sign in the middle. Opposite sign. So whatever sign's in the denominator, plus, then we use minus. If there had been a minus in the denominator, then I would use plus over plus. Remember that a little bit from algebra? It's called the conjugate. That's how you get rid of the root. Again, it's because of the plus. If there was just a root 3 in that denominator, then yeah, I would just multiply top and bottom by root 3. That would have been simple. But because of the pluses and minuses, I'm telling you, they're what bring in all the hard things in algebra. So you got to do that. Now, one's a little bit longer than I expected. Now we got to FOIL this thing out on the top. So -1 times root 3, negative root 3, -1 times -1, positive 1. Then this guy, his turn, root 3, plane 3, root 3 times -1, negative root 3. We good so far? So I just FOILed the top. Now in the bottom, I'm going to FOIL this out. Root 3, remember root 3 times root 3 is plane 3, because it's root 9, which is plane 3. Remember that? Remember two of the same roots make a plane? Like if you had like root 7, that's just plane 7, because root 49, which is plane 7. Remember that whole thing? So root 3 is plane 3. Root 3 times -1 is negative root 3. Then 1 goes to both these, plus root 3 minus 1. You okay with that FOIL? Top and bottom, two FOILs. Now, why are we doing all this? Well, we're trying to get rid of the root from the bottom, huh? Did we do it? Yeah. Those are gone, aren't they? That's why that works. You see why we use the opposite sign? See how that worked? That's why you do the conjugate with the opposite sign, because then you get 1 minus 1 plus and the roots drop out of the bottom. And so, okay, so what is all this? What becomes of all this? We're like having to remember a lot of root rules from algebra here. On the top, let me add these first off. 1 and 3 is 4. Right, let me just bring it down here. 1 and 3 is 4. And what is minus root 3 and minus root 3? Anybody remember that from algebra? It's minus 2 root 3, because there's an invisible 1 and an invisible 1. They're like roots. Do you remember roots from algebra days? It's minus 1 root 3 and kind of being scribbly there. Minus 1 root 3 and minus 1 root 3 is minus 2 root 3. It's like adding x's or something. Minus x and minus x is minus 2x. Roots are like letters. Same rules as letters. So like roots, like terms. So we get all that. Then on the bottom, what happens on the bottom? 3 minus 1, 2. Would you believe that we're not done yet? We have one more step. We are so close. Yeah, can we just go 2 into 4 is 2 and we're done?
No.
Why not? Why can't we do that?
Because you still have the negative.
Glue. Remember, the top is Costco glue. The top is saying, if you wanna do something with me, you buy the whole package or none of it. Right? Remember, pluses. Everybody getting that rule? That really becomes increasingly important as you move on. Things plus or minus are a package deal, like Costco, Sam's Club, those warehouse stores. Package, you can't go in there with your scissors and cut the thing and say, I just want 1 milk or 1 spaghetti sauce or whatever. They're packaged together, glue, buy the whole, all or nothing. So that minus sign says, no. If you're going to cancel anything up here, you do it all or you do nothing. You can't just do the 4 or something like that. Right? If that was times up there, we could do just 1. But plus and minus is right. Let me put it back where it is. It's 4 minus 2 or 3. What do you do then? You can do them both though. Both is fine. Or you could just break it up over a common denominator. You know what I mean? It's just 4 over 2 minus 2 root 3 over 2. Then these cancel. 2 goes into 4 2 times. There's our answer finally. 2 minus root 3. That was something. So that last step, let me show you one other way you could do that last step. You could have just canceled the 2 into the 4 and that other 2 at the same time. That's fine. If you do both, Costco will let you buy both, the whole package, right? You can do both. That's okay. Or you could just break them up over common denominator. Same thing. Everybody's tracking with me on that last step? So if you're going to cancel with plus or minus, you're going to do both of them. And if one of them can't go, like what if there had been no 2 there? Well, that means you can do nothing. Because again, you buy the whole package, because there's really a 1 there, 1 there, a 1 there, and 2 doesn't go into 1. So you go into both or you don't go, right? With pluses and minuses, it's a package deal, both or nothing. So we did have a 2 there. We can go into both, so it's good. There's our answer. Just as easy as that. That was a tough one. Tangent all the way to there. Questions? All right, let's move on. Well, that one will be on YouTube. What did I mess up? 10. Yeah, do number 10. So there we go. Let's try number 10. So basically, it's another one of these. Do it backwards. See how they're giving you the right side again. They want you to go backwards to the left side. Just having us practice these formulas forwards and backwards. So can you work that one backwards? Can you make it back into just like one sine or cosine? Go from the right side back to the left. Let you look at that. Does this one come from a sine or a cosine? Yeah, it's sine, cosine, cosine, sine. That's the sine formula, isn't it? Right? So it's not the cosine formula. The cosine does double cosine, double sine. So it's not that one. So it's the sine. Okay, and the two angles are clearly 20 and 10. No mystery there. And then what? Is it plus or minus between them? Yeah, because sine always does the same. He's our friend. He's always the same. So like that. Good. So that's the first step they want you to do. And then that's the sine of 30 degrees. So, and then they want you to figure that out. Can you find the sine of 30 on the unit circle? So we'll draw the unit circle. Put 30 degrees on there, which is right here. 30, which is over a lot, up a little, over the large amount, up the small amount, only up a half. So that's over root 3 over 2, up a half. Cosine, sine, we're talking sine, so they want the half. There we go. Good. Working those formulas backwards, a lot better than that last one, huh? With the tangent. Okay. Okay. So try that one. Same kind of thing. They want you to work it backwards. So if we go backwards, is this one a sine or a cosine?
Sine.
Sine again, huh? Because again, it's sine, cosine, cosine, sine. So that's the sine formula. So then the two angles are 2 pi over 3 and pi over 6. Now, are they added or subtracted? Well, I mean, what sign do I do? Plus or minus in the middle there? Minus, because he's our friend. He's the same. So he's the same, okay? So now I've got to combine those into one angle. Right? That's always what we do, right? Looking back to the one we just did a minute ago, right? The 20 and 20 and 10, we made 30. Right? Got to make them into one angle. So how do we subtract those and make them one angle? Common denominator, yeah. So top and bottom by 2. So that'll be what? 4 pi over 6 minus pi over 6. Like that. And so then that's what? That is sine 4 pi over 6 minus pi over 6 is 3 pi over 6. Which is pi over 2, right? You just reduce that fraction, right? 3 goes into 6 2 times. So that is sine of pi over 2.
And that would be like a 90-degree angle, right?
Exactly. So we can go find that one easy. Everybody good to hear so far? Austin?
Could you just find the...
Make them into degrees first? Yeah. Totally. If you want to do it that way, feel free to do that. Yeah, like make this, just plug in the 180. What would that be? 120. This comes out 120. This comes out 30, and then subtract them. Same thing, or you could just do it now. Put in the 180. Remember, pi is 180, right? So this is the sine of 180 over 2. This is the sine of 90. Or back here, Austin was saying, can we just put in the... Back here, could I just plug in the 180 at this point for these guys? You totally could. You'd find out that's 120, that's 30. You'd get right down to the 9. Might be easier way to go. Get right to the 90 right away. Either way, now we're at sine of 90. Can we find this? Let's draw the unit circle. Find the sine of 90 degrees. Where's 90? Straight up, right? 90 degrees. So what are the coordinates at 90 degrees?
0, 1.
Yeah, over 0, up 1. Right? That one's not small, medium, or large. It's over 0, up 1. So that's cosine, sine, like always. The first one's cosine, second one's sine. What do they want? Sine? 90 degrees, 1. That means all of this is a fancy way to say 1. Yeah.
Pi over 2 is on the unit circle at 90 degrees.
Yeah, you could just do that. Yeah, you don't have to convert to 90. If you're just looking at the unit circle and it just says pi over 2, just go there. Yeah. We have a lot of different ways of doing things. Is that good? Everybody good? So now we'll dive into the last. So we've done all the basics. Now they're going to throw the hardest thing, which 40 over 41. B's in quadrant 2, wasn't it? Yeah, quadrant 2. Okay, and what do they want? Cosine of A plus B, sine of A plus tangent. Okay. So, all right, so they're giving me a bunch of information about sine and, well, the sine of two different angles. We're talking about an A and a B, two different angles, and then they're going to ask me to do the cosine of A plus B formula of the sine. They're going to ask me for all three of these, really. They want all three of them. So to do that, to be able to use the formulas that they want me to use, I have to first find all the angles of all the other trig functions for those angles. So in other words, I've got sine of A, I've got to find cosine of A, because I'm going to need it in the formula. And over here I've got sine of B, I need cosine of B. So I need cosine of both those, basically. They're giving me sine of A, and they're giving me sine of B. But I also need to find with them the cosine of A and the cosine of B, because when we use these, notice what's in these formulas on the right side, sines and cosines of A and B, huh? And eventually tangent, which is sine over cosine. So I need sine and cosine of A and B, don't I? Mm-hmm. So you see what I need to find? They're giving me the sines. I need to find the cosines. How do I do that? I draw those triangles. Remember those triangles with the quadrants and everything? So it's more of that. So let's do that. If you felt kind of so-so on that before, this is good. You know, get a second look at it. Maybe get a little more comfortable than you were before. So I'm going to draw the triangle. I'm in quadrant number 1. It's going to be exactly the same way we did it before. Quadrant number 1. So we start at the origin, and you go into quadrant 1. And then which grid line, which axis do I hit when I make these triangles? Remember, we always want to do, you don't want to go like that, huh? You never want to go to the Y. You always want to go to the X, because that's because all of our angles started from 0 degrees on the x-axis. So that'll make them the same. Okay, so you go to the x and you put your angle, well, not theta. I was going to do theta. In this case, it's A, isn't it? It's A instead of theta. And then we're going to remember the Sohcahtoa. Sohcahtoa. What is sine? Opposite over hypotenuse, yeah. Opposite over hypotenuse. So that means, and this is the adjacent side and the opposite side and the hypotenuse right there. Make that a little better. So, yeah. So they're telling me what? The opposite is 15. The hypotenuse is 17. And so I need to find the adjacent side there. And you know what we do? What do we do? The Pythagorean, right? So we do that. Get rid of this. So we do the Pythagorean. A squared plus B squared is C squared. And which one's the C whenever we do the Pythagorean? It's always hypotenuse, so 17, exactly. And the A and the B doesn't matter which is which, you know, you can switch them around. Doesn't matter. So we get A squared, and this will be 225. This is 289. Subtract 225. A squared is 64. Like that, and then root it. A is 8, huh? So this side is 8, the other side is 8. Okay, great. Now why did we do all that? Because we wanted the cosine. So now we can say, okay, cosine of that angle A.
Is 8 over 7.
Yeah, it's Sohcahtoa. Let me write Sohcahtoa again. Right on. Sohcahtoa. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. Cosine is 8/15 adjacent over hypotenuse. So now we've got the cosine of A.
Isn't the hypotenuse 17?
Oh, thanks. Thank you. 8/17, adjacent over hypotenuse. 8/17. Oh, yeah, I circled the opposite. That was craziness. Adjacent over hypotenuse. Good there. So now we got to do all that again now for sine. Because we got to find the cosine of B. See how there's two different angles? There's A and B, which is going to be two different triangles. They're two totally different angles. And for each of them, we need sine and cosine, for both A and for B.
It also wants tangent.
Well, we'll get the tangent by sines over cosines.
Okay.
Yeah, we will, yeah. Or we could just do, yeah, maybe it'd be good just to do that right now. Let's do that right now. I like what you're saying. Let's do that. Let's just get tangent also. So what would be the tangent of A? Tangent is toa, opposite, over adjacent. Let me get it right this time. 15 over 8. Yeah. So let's get sine, cosine, and tangent. Good idea. Because we're going to need all three. That'll be quicker than trying to do sine over cosine and flipping stuff. So there we go. We got sine, cosine, and tangent for A. And now we need sine, cosine, and tangent for B. Once we have all those pieces, then we can put they want all three. It's like a super long problem. These three, these number 12, 13, 14 are super long. So once we get all these pieces, then we can do all these formulas by plugging in the pieces. All right, we good to there? So let's do the other triangle now. So come on over here. Here you're in quadrant 2. So go ahead and make your angle B, this angle B now. Make it in quadrant 2, do the Sohcahtoa, do the Pythag. Let me give you just a second, see how you're... So we do our... And you put B right there at the origin, huh? Angle B right at the origin. And the sine is opposite over hypotenuse, so opposite over hypotenuse. So this is opposite, adjacent, hypotenuse, and so it's going to be 40, hypotenuse is 41, like that. And so we do the Pythag thing. This out of the way. The Pythagorean theorem. A squared plus B squared is C squared. So that's A squared plus 40 squared is 41 squared. A squared. Whoops. Supposed to be a 2 there. 1600, what is 41 squared?
1681.
Oh, thank you. All right, 16, oh, that's nice. And then subtract the 1600.
8 is 9.
Yeah. So we go on, 81, root it. So A is 9, very convenient. So that side's 9. Okay, so now we can get cosine and tangent for that angle B, right? We're doing all this stuff for the A angle, and now we're doing all the stuff for the B angle, which is in the second quadrant. Oh, I should put the right signs. I forgot about, well, in the first one, it was first quadrant, so everything was positive, huh?
Yeah.
That's good, but I'm going to have to be more careful here in the second quadrant. We'll have to get the right pluses and minuses. That's often the issue on these, is the sign. You get one little sign off and everything's off. So, all right, so where are we at then? So we have sine, so I don't know if I have any room here. Squeeze it in over here. So now I'm ready for cosine of angle B. What's the cosine going to be? adjacent, yeah. So it's 9 over 41. Yeah, and what, here, let me get them first, then I'll do the signs afterwards. And then tangent is,
40
yeah, opposite over adjacent, 40 over 9. Yeah, now let's do the right signs, right? We're in the second quadrant. Remember how it goes. All students take calculus, right? So in the second quadrant, sine is positive, but all the other trig functions are negative, aren't they? So cosine's got to be negative, tangent's got to be negative, sine is positive. Or, yeah, you guys were just looking at the triangle. That's a great way, too. It's the negative on the 9, huh? It's back 9, up 40. That's the easy way to see it, too. Anything that has the 9 in it's going to be negative. Either way will work. You can do that either way. Is everybody seeing that? Just do the all students take calculus. We're in the sine, which means only sine is positive, and his upside down, cosecant. The other 4 trig functions are negative in the second quadrant. So cosine and tangent are negative. Okay, so now we've got all the pieces. We can build the puzzle. We have sine, cosine, and tangent for A. We have sine, cosine, and tangent for B. So now we're ready. What they're asking us to do is they want the cosine of A plus B first. So let's do that. So number 12, part A. They want the cosine of A plus B. We're using the formula that we've been using all hour and a half here. Cosine, sine, sine, and the angles never change order. A, B, and is he our friend or not?
No.
He's not. He changes sign minus, right? Switches. Opposite. Okay, so there we go. So now those are 4 pieces. We just go grab them. So first off, cosine of angle A. That's 8 over 17. Times. There's no symbol between them, so that means times, huh? Cosine of B, which is, negative 9 over 41. Minus, remember there's the minus right in the formula. That's in addition to any items that are negative themselves. Be real careful with signs. Most people do a great job on this, and they just mess up one little sign somewhere. So be real careful with your signs. Make them big. Be real clear which ones are there. Sine of A, 15 over 17. Times the sine of B, which is 40 over 41. Okay, so then just use your calculator. So minus 72 over whatever 17 times 41 is, 697. Minus, there's that subtraction in the middle, 15 times 40. So that's 600 over 697. So that's minus 672 over 697. Yeah. Does that reduce? I don't think so.
No.
It looks ugly. Yeah, I think that's just it right there. For that first one, now we got to do sine of A plus B and tangent of A plus B. Good for that first part? So we got all those pieces, and then I just put them in their slots. Let's try the next part. Part B says sine of A plus B. Sine of A plus B. So we use the formula. So that one is sine, cosine, cosine, sine. He's the one that switches order halfway, right? Sine, cosine, and then it swaps order, cosine, sine. The angles never change. They're just always same order, A, B, A, B. And sine is our friend. He stays the same sign. So the plus stays plus. Same there. Okay, so now we just plug in the 4 pieces of the puzzle. So we go back and get them. So first off, sine A. Sine A is 15/17 times cosine B, wherever that is, cosine B right here, minus 9/41 plus cosine A. Cosine A is 8/17 and times sine B. Sine B is 40/41. Like that. All right, so then just multiply, use your calculator, multiply top times top, bottom times bottom. So minus 135, 17 times 40, that's the same number was a minute ago, huh? 697 plus, what's that, 320 over 697, and then subtract those. Getting 185 over 697. I assume that's not reducible because it just looks.
Okay.
What's that? Does it reduce?
Well, no, the sine of B is 40/41.
Right.
So,
Right here.
but going back, wouldn't it be the same?
Same as what?
Well, because you have cosine, or you have sine.
Oh, this is sine A. This is angle A. That one you mean?
Yeah, and then sine of angle B.
Which is right here, 40/41.
Yeah.
Which one are you looking at, Chanel?
Okay, so if you're factoring, I'm confused of the -9/41. You have 15/17 times
So-
-9/41.
Right, because the sine of A is 15/17 and the cosine of B is minus 9/41.
He gets that one from the second triangle.
Yeah, this is B,
But I thought it was.
and this is sine of B, and this is cosine of B.
Oh.
We good? So I'm just getting them back over here. So here's sine, cosine, and tangent for
I
A.
was thinking.
Distribution. She's
Okay.
confused because we started with just two numbers, and then now we switched them to 4 different ones.
Oh yeah, no, I see. Good question. Good question. Yeah. Let me address a good question.
Wait, what?
I remember when I was in junior college taking these kind of classes, I remember looking at things like sine of A plus B and thinking, well, that's just sine of A plus sine of B. You know, that's actually not true. It sure looks true, doesn't it? And I thought it was true when I was just getting going with this stuff. You can't do that because this is not actually multiplication. It doesn't mean, it isn't distribution because it's not sine times A plus B. It's sine of A plus B. A plus B is plugged into the toaster. That's why I made up all that toaster talk to help students start thinking about functions. Because I know how you think. I used to think that way when I was taking these kind of classes. And I would think, oh yeah, why don't they just do that? Well, it's because it's not multiplication. That's like f of A plus B or something. You can't just multiply. It's not times. Well, it's in fact. Well, what about this? This actually these formulas we have today, these aren't multiplication either. That's why there's like 4 of them, and it's weird, and it's because it's a special formula. It's not just multiplication. So this is not true. It's a special whole formula. That's what these are. They're very special. They're not just multiplication. On that, I know it looks like you just kind of feel like, hey, anytime there's parentheses, I can just multiply. No, you got to remember, anytime it's a function in front, like sine, cosine, tangent, that's like f of A plus B. You can't just multiply. That's not multiplication. It's plugged into the function.
Got it.
Yeah, good question. Why isn't it just that? Yeah. All right, so now one more. So it's that whole special formula. Now we got to do the tangent one. All right, so then, and we're finally done with this problem. So part C, let's do the tangent one. So tangent of A plus B. And so that's not multiplication. It's the whole special formula, which is tangent A plus tangent B over 1 minus tangent A times tangent B, right? Is that good like that? So the sign on the top is the same, and the sign on the bottom is the opposite, so that's all good. So, so now we just got to go get those pieces. Tangent of A, what is it? I don't know. Going back, tangent, there it is, 15 over 8. So that'd be 15 over 8 plus tangent of B, bless you. And I'm going to put tangent of A in the bottom also. 15 over 8 times. Then tangent of B. Tangent of B is something minus 40 over 9. Here. And there. Good so far. This one's going to be a mess, I think. Yeah, this is going to be several steps. Okay, so we plugged all the tangents in there. So, okay, so to add those two things on the top, we're going to have to get common denominator, aren't we, when you add fractions or subtract them? So that means multiply top and bottom of this one by 9, top and bottom of that one by 8, to get common denominator 72 up there. So that's going to be what? 9 times 90, 135 over 72. Minus, write that minus sign, going to be minus 320 over 72 all over. Now on the bottom, they just multiply, don't they? And it's going to be 1 plus. Everybody see that? Because of the negative times negative. Two negative fractions are going to multiply to be positive. 15 times, and it's going to be over 72. 15 times 40, is it? I think it's 600, isn't it? Yeah. Everybody good to there? It's a mess. And easy to mess up on the signs. Everybody see what happened with these two negatives? Negative times negative, made positive there. Okay. So now, what are we going to do? Well, just subtract those fractions on the top.
Is the 135 negative?
I don't think so. Or 9 times 15. Tangent A. Tangent A wasn't negative, was it? No, just 15 over 8. So, and then subtract those two. 135 minus 320. Minus 185. So that top becomes minus 185 over 72 all over. And the bottom, we're going too quick. Okay, I just subtracted the two on the top. And they made minus 185 over 72. Now on the bottom, how do I add these two?
Oh, you have to make it a fraction.
Yeah, and what do you do with that one?
Multiply it by 72.
72 over 72, huh? Yeah, good, good. Just make that 1 72 over 72. It's just a fancy 1 that way, and you can add them. You get 672 over 72. Like that. And then grab this denominator. Now, that is just one thing on the bottom. I can just flip it up, right? There's not two things added, or I can just quickly just flip it up like that. And so then we get minus 185 over 72 times 72 over 672. We're so close. And that's going to equal, these will cancel, minus 185 over 672.
And it does not reduce.
Doesn't reduce. Good. I don't want it to. We are done there. So we did. That was a long problem. So we did sine, cosine, and tangent for A and B, right? We had all three for A and B. We had to do all that triangle work for A, all that triangle work for B, getting sine, cosine, and tangent for A, sine, cosine, and tangent for B. Then we had to plug them into the formulas and work everything out. They're just making us masters of these formulas. Question, comment?
You get another example?
What's that? Want to do one more? Yeah, let's do one more. Yeah. Okay. So there's the beginning of the question, and we know what before we even go further, we know we need to do the triangle for both of them, and we need to find sine, cosine, and tangent for A, and sine, cosine, and tangent for B. So go ahead and do that. Draw the triangles and find all the angles. Do the Sohcahtoa and the Pythag. Okay, so I'll draw the triangle. We're in quadrant 2. We always go to the x-axis, right? Angle A is always at the origin. You know the Sohcahtoa thing. So tangent is opposite over adjacent. So forth. Now, if you want to just skip the signs, you could do that and then just figure them out in the end. It's whichever way you want to do it. So this is opposite. This is adjacent. And this is hypotenuse. So I don't know if you recognize 3, 4, what's the other side?
5.
Yeah, they do 3, 4, 5 a lot. So if you see that, you can just skip the Pythagorean. It's got to be 5. But if you don't remember that, that's fine. You'll get it. Just a squared plus b squared is c squared. So 3 squared plus 4 squared. The c is always the hypotenuse. So 9 plus 16 is c squared. 25 is c squared. And root it, c is 5, as we knew. Okay, so now you've got, what are you going to do with that? Well, you've got the tangent already. They started us for A with the tangent, so you need sine and cosine, right? We need sine and cosine. So I'll write them in here. Sine of A is 4/5. And cosine of A, it's going to be 3/5, but maybe negative. Let's decide upon the signs, the plus and the minus kind of stuff. So I'm in the second quadrant, right? All students. So sine is positive in the second quadrant, and his upside down cosecant, but everything else is negative. So that means tangent's got to be negative, which he already is, and cosine's got to be negative, huh? Tangent's negative, cosine's negative, sine is positive in the second quadrant, right? All students. Take calculus, all students. So sine is positive, and his upside down, everything else is negative. So cosine and tangent are negative. Or you could have just put the negative on the 3. That's what the negative's coming from, huh? Back 3, up 4, positive on the 4. So anything involving the 3 is going to have a negative. Either way, we good with that first half? So we have sine, cosine, and tangent for A. Now we have to come over here for B and draw a triangle for B and find sine, cosine, and tangent for B. Which is quadrant 1, which is nice. Everything's positive in quadrant 1. So Sohcahtoa. This is adjacent. Opposite. Hypotenuse. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So it's going to be 7 over 8, like that. Good on that. And then we find the third side by the pythag. So you're going to need to do the pythag to find that third side over there. Am I racing ahead of you? Good to there. So do the pythag, find that third side. So that'll be a squared plus b squared is c squared. So 7 squared plus b squared is 8 squared. So that's going to be 49 plus b squared is 64. And then solve for b there. Subtract the 49 from both sides. And so we get, bring it up here, b squared is that 15? And then root of 15. So there's b, root of 15. And so now we have cosine already. We can get sine and tangent. For angle B. So the sine of angle B, sine is opposite over hypotenuse. So that's, and it's root 15 over 8. And then tangent of B, TOA, opposite over adjacent, root 15 over 7. All right, we have all the pieces for the puzzles. Good. We have sine, cosine, and tangent for A. We have sine, cosine, and tangent for B. We double-checked our angles, plus or minus. You want to make sure they're right signs. This is quadrant 1. Everything's positive. The other one, angle A, is quadrant 2. We made sure that's right because all students, take as students, sine is positive. The other ones are negative. Looks good. So now we go to our formulas. So they want, first off, they want sine of A plus B. I guess they're switching the order this time. They want sine of A plus B first. So, okay. So 13 part A sine of A plus B. Right, sine of A plus B. So according to the formula, that is sine, cosine, then he switches order. Cosine, sine. You always keep the same order on the angles, A, B, A, B. And sine's our friend. Whatever he starts with, keep it the same. Plus. Okay. So now we go back, and there's 4 pieces. We go grab those 4 pieces. So sine of A, what's that? Oh, right here. 4/5. Sine of A is 4/5. So everybody good here? We're using the whole formula. We can't, like we talked about, we can't just distribute. It's not just sine A plus sine B. It's this whole special formula. That's what today's been all about. And then cosine B, 7/8 plus cosine A minus 3/5 and sine B, root 15 over 8. Good. And then coming on down, multiply those together. 4 times 7, 28 over 5 times 8, 40. Plus, and then negative 3 root 15 over 40. Just put them together into one fraction. 28 minus 3 root 15 over 40. And do you know you can't subtract those on the top? You can't, if that was a 28 root, remember from algebra? If that was 28 root 15 minus 3 root 15, then I could subtract them. They got to have the same roots. This is kind of like 28 minus 3x or something. You can't subtract it, right? If the 28 had a root 15, then they'd be like terms and I could subtract them. But they're unlike terms. One of them has a root 15, one of them doesn't. So they just stay that way. There's that one. That's as far as we're going to get. So you could do the B and the C. It's the same thing, putting those pieces